Today we're going to talk about life cycle of star. Stars are massive shiny balls of hot gas which are held together by gravity. Although they look small, they are actually large bright objects like the sun. They look so small because they are far away. The nearest star is Alpha Centauri and it is 4.3 light years away. All the energy in a star is produced in its center or core by nuclear fusion. This energy emerges from the star as heat and light so that the star appears to glow. As I said, the star is shiny. For example, the sun. As you can see, the sun is a huge ball of hydrogen. Inside the sun, the hydrogen atoms are heated so much so they turn into a plasma state where electrons no longer orbit the protons in atoms. Nuclear reactions at the center or core of the stars provides enough energy to make them shine brightly for many years. Fusion already happens naturally in stars, including the sun, when intense pressure and heat fuse hydrogen atoms together, generating helium and energy. This process is what powers the sun and makes it so hot and bright. Researchers who work on fusion energy are essentially trying to make tiny stars here on Earth. A star's life cycle is determined by its mass. The larger its mass, the shorter its life cycle. A star's mass is determined by the amount of matter that is available in its nebula, the giant cloud of gas and dust from which it was born. Let's know how the star is formed. The young star reaches the hydrostatic equilibrium and the gravity compression is balanced by its outward pressure, giving it a solid shape with a reasonably stable size, which is the main sequence of the star. The core temperature reaches the point for the fusion to commence. The hydrogen nuclei fuse together to make helium. There are two types of main sequence stars, a red giant, which is a large bright star with a cool surface, and a red dwarf, which are very cool, faint and small stars. The nebula, the stars that are formed in clouds of gas and dust, they are known as nebulae, and as you can see in the picture, this is the nebula. A stellar nebula is where a star begins its life. Nebulas are large clouds of dust, hydrogen, helium, plasma, and gas that spread out in a large area of space. Stellar nebulas are often hold hundreds of stars. Nebulas may seem very large, but their mass is extremely low. The path the stages follow beyond that depends on the mass of the star. Small stars like the sun will undergo a peaceful and beautiful death that sees them pass through a planetary nebula phase to become a white dwarf, which eventually cools down over time and stops glowing to become called a black dwarf. The earliest stage in a star's life is when it is a protostar. A protostar is a cloud of heated dust and gas with a large mass. Protostars are often hard to spot due to the large clouds of dust that surrounded the star's core. Protostars also have strong magnetic fields, causing a strong outward flow of particles into space. The red giant. During the red giant stage of a star's life, it becomes very bright and emits less heat than regular. This is thought to be because there is no hydrogen in the star's core to fuel nuclear fusion. Stars spend a few thousand to a billion years in a star's life. Its core runs out of helium, causing fusion to stop. And as you can see, this is a star in a red giant stage. The planetary nebula is a stage in the star's life as it comes closer to death. During this stage, a star's outer layers grow larger and drift into space, forming a planetary nebula. Overall, during this stage, a star sheds most of its outer layers, leaving the core for the next stage in the cycle. And this is a star in a planetary stage. White dwarf star. During the white dwarf star stage, the star has a blue-white colored core, which is the remains of the planetary nebula. The white dwarf star also no longer contains any more nuclear fuel. While dwarf stars have a small size but a large mass, and glow faintly, due to leftover energy. And as you can see, this is a white dwarf star. On the other hand, massive stars will experience a most energetic and violent end, which will see their remains scattered about the cosmos in an enormous explosion called supernova. Once the dust clears, the only thing remaining will be a very dense star known as a neutron star. These can often be rapidly spinning and are known as pulsars. If the star which explodes is especially large, it can even form a black hole. Massive stars begin their lives inside of stellar nebulae, similar to the average protostar. The massive protostar shares many characteristics with the average protostar, but unlike average protostars, massive stars have a much larger mass affecting its size and brightness. And this is how massive stars look. Supergiants are the largest stars in the universe in terms of physical size. This is due to the outer layers of the star expanding. They have cool surface levels but are very bright due to the star swelling because of lack of hydrogen fuel. As you can see, this is a red supergiant star. Supernova. The massive star is not similar to the average protostar. Massive stars evolve pretty quickly into bright supergiants. When a supergiant does not have any fuel left, it can suddenly explode due to pressure. Within hours, the star burns millions of times brighter. This explosion is called supernova. As you can see, this is a picture of a supernova. Black hole, the biggest stars having 40 times the mass of the sun, most likely will become black holes when they die. A black hole is an object with gravity super strong that nothing, not even light, can be able to escape. And as you can see, this is a black hole. Neutron star. After a supergiant explodes, the remaining material from the star is left behind. The star forms due to the pressure from the gravitational collapse. This material may form a neutron star. A neutron star is the remains of the high-mass stars. They are smaller and denser than the white dwarfs, and this is the last stage in the star's life before it dies. Thank you for watching.